For obtaining permission to perform laboratory work, you need to have a notebook with the written theoretical part and the methodology of the practical part with you. On the optical bench, we'll set up the devices in the following order: mercury lamp, convex lens, green light filter, Newton's ring observation device, convex lens, iris diaphragm. Next, turn on the mercury lamp and let it warm up for 7 to 10 minutes. Once the lamp has warmed up, Newton's rings will be visible on the screen. For better visibility, you can turn off the lights. Count how many rings are clearly visible. There should be from 7 to 10 on each side. After, measure the position of the rings on the left and right using a ruler. For clarity, let's examine using the fourth ring as an example. Measure with a ruler from left to right the first point of contact with the ring, and the second, then subtract the smaller from the larger, thus obtaining the diameter of the ring. When doing this, you may accidentally move the spout of the ruler. Also, you could lose count of the rings and record the dimensions of the wrong ring. Pay attention. Let's break it down in practice. Let's find x1 and x2 for each ring. We ended up with 9 of them. The sizes of the rings depend on their quantity and can vary from time to time. First, you can record x1 of all the rings, after x2 of all the rings, just as we did when carrying out the work. You can also record x1 and x2 rings together. Let's start with the 9th ring. x1 is 144 millimeters. x2 is 2 millimeters. Next is the 8th ring. Its dimensions will be 139 and 6 millimeters, respectively. After we found the dimensions of the 7th ring, and we got 134 millimeters and 11 millimeters. x1 of the 6th ring turned out to be 130 millimeters. x2 is 50 millimeters. The dimensions of the 5th ring are 129 millimeters and 20 millimeters. x1 of the 4th ring turned out to be 124 millimeters. x2, 26 millimeters. Next is the 3rd ring. Its dimensions are 118 and 32 millimeters, respectively. The x1 of the 2nd ring is equal to 111 millimeters. x2 is 39. Finally, for the 1st ring, x1 is 103 millimeters. x2, 47 millimeters. Then ask the laboratory assistant to check the truthfulness of the measurements and enter them in the table. When noting down x1 and x2, make sure you haven't mixed up the ring sizes. Let's break down the execution of the practical part step by step. First, we'll determine the ring combination to calculate the lens curvature. The lab assistant will provide this to us. For the second step, we'll find x1 and x2 for each ring. In our case, there are 9. Subtraction from x1 and x2 will give us the ring diameter. Find the radius of each ring. The third step is to find the lens curvature radius using the previously given combination. Find the average value of the radius of curvature of the lens. Finally, we'll calculate the systematic error of the radius of lens curvature using a formula. Record the data in the table. The received data is entered in the table. After successfully explaining the theory, we'll get our first signature. After completing all the practical exercises from the lab and presenting the final result in the form of a table, we'll get our second signature. For different lab work, you'll need to answer the control questions in detail. Also, before the defense, we strongly recommend learning to independently derive the formulas for Newton's rings and the formulas for finding the maximum of interference. For easier understanding, we will leave links to video tutorials in the description. After successfully defending your laboratory work, you will receive the final signature. Good luck.